So today, a bit maybe less technical topic, but something very close to my heart, especially as I'm leading data science at AltaML. Applied data science, what does it mean? So very fast about AltaML. AltaML is a pretty young company, 2.5 years old, but growing dynamically. Around 100 people, 3 offices. We are opening applied AI lab in Calgary Center, where people who may know about programming, know about machine learning can go and get a work placement, like 3 months internship working on industrial data with real world, with applied problems. So if someone is looking for a job internship, that's more community-based school or lab, where we're working with ATB, Spartan Control, Suncor to give people some work experience. But AltaML works closely with industry, takes their data, their problems, and domain expertise, and adds our talent, methodology, and tech stack to build applied ML solution that then those companies can use, or maybe we can, if there are general problems, maybe we can build products. So this word of applied machine learning is very close to my heart. It's quite different than academia, actually. Data science has pretty short history, as you probably know. The first data science team was created at LinkedIn by Dijay Patel in 2008. They had a lot of data, and they started exploring these connections, these graphs of social connections, and build the tool called People You May Know. And that tool performed way better than any ads. And that made LinkedIn realize that there's a need for some team that will explore knowledge from the data. And then it all skyrocketed. Harvard Business Review, the sexiest job of the 21st century data scientist. That article actually was written by Dijay Patel. He was trying to promote hard, find people to actually work with him. And he quite succeeded. 2017, 4 data science roles in top 10 fastest growing jobs in US. ML engineer, data scientist, big data developer, and director of data science. I guess they realize some management is needed. And that's Google trend for the data science. As you can see, it's growing and it keeps growing. But is it really so short history? Even ancient Romans collected data and information about their empire. And then there was a lot of around statistics, which actually surprised me when I learned about it. Statistics is pretty young field. It started in 1662, and probability theory was in 19th century. Beginning of this century is where the hypothesis testing and working on the small data set started. And then, of course, computers accelerated it. So a lot of people tell that data science is just a sexy name for statistics, in the words of Harvard Business Review. But for me, it's more about extracting knowledge from the data and using it. So again, this applied side. So the question, would you call statistics a sexy name for math, or computing science sexy name for math as well? No, they're slightly different, and there is a different need at the end. In 2008, when this first data science team was created, the characteristic of data scientists was a lot of soft skills, and then Venn diagram, but mixed between computing science, domain expertise, statistics, math, pretty much a unicorn that can code. So hard to find individuals that can do everything. Well, the perception since that time changed a lot. Now it's more a team sport. It's where you have some engineering side that can deploy the models, that they can actually wrap it up, make sure to maintain it, that models are running. You have analysis, some data analysts that can do EDA or explore the results or find some patterns. Data wrangling, very important, getting data, making sure data is very in the proper format. handling big data. Of course, some science research, a lot of people think data science is only about that, but it's not. If we focus only on that, it would be very hard to do something. And then there's someone needed to actually represent business side, make sure that whatever is developed is still close to business. But it's not only about machine learning models. So here is a quick poll from Google where they ask people what's their expectation, what data science, what takes most time. As you can see, most people said this green part, optimizing machine learning algorithm. But in reality, we know it's not really that. When you actually want to bring some models to production, there is a ton of problem definition, collecting that data, handling the data, then building some infrastructure, optimizing models, sure, you're running it through some algorithm, and then in the end, it's a lot about integration. Also, when you deploy the model, all of a sudden, world changes, moves forward. Maybe there will be random pandemic happening around and all the old models don't work anymore. So the data changes, how do you change the model? So the first talk a bit about kind of reinforcement learning model of a contextual multi-arm bandit. It would actually cut this change of trends in real time and would adjust. So what should we develop? Should we change it? Should like just maintenance of the model? There are some methodologies, and the most popular one, CRIS data management, is from 1996. Pretty old, but still pretty accurate. It consists of a few steps. When you're stating the problem, you have to understand this business domain, what exactly you're solving, and then what data you have, prepare this data, model, evaluate, deploy, collect feedback, and go on and on. But then often you will just go from step 2 to step 1 and so on. IBM updated this model with Assume Analytics Solution Unified method, pretty much the same, except they realized, well, when you deploy the model, you actually cannot leave it on production. You have to operate, optimize, maintain it, and keep going with this loop. Year later, Microsoft Team Data Science process, very similar, but I think I like it the most because it's well structured. You can see where it goes. It outlines some better steps here. Except probably you never have an end, you're going back to start and keep working. So as you can see, these models already telling you that it's not only about building this model and optimizing it. There's much, much more to it than just building model. It's a small part, but very important, but the most important part probably is defining this business problem right. We have situations often where people want some models and then those models they cannot use them. Even at AltaML, we thought we understand the business process. We took everything and then we're building the model and then we're looking at the performance. And well, it's not maybe not the best from this metrics perspective, but then a senior machine learning developer joined the project and reviewed the business process, took that business process where the model actually is, and realized we were using wrong metrics. This is not how the model will be used. When you're actually looking at benefits to the company, it would be $2 million per year, even with those traditional metrics not being good. So it's often very important not to look just on the metrics. So we have actually almost half of the company is called ML developers. What does it mean? I don't like using data scientists as a term, mostly because when you're telling I'm data scientist, it's a question like, what do you do? Are you doing everything, or are you specializing in one part? So to distinguish that, we have data science team, of course, but there are different roles, and a lot of them is ML developers. And now there's a bit of a confusion because it's a new term. A lot of people will use it as people who build machine learning infrastructure. But for me, these are software developers, backend software developers, DevOps. ML developers, as the name would suggest, are person who develops ML models. So it's like software developers are people who develop software. It's a developer, not a hacker scripter. So borrowing as much as possible from the software development world, replaceability, versioning, quality assurance, and a lot of focus on the business value, asking this question over and over, are we solving the right problem? And knowing when to stop modeling. This is a very important part where often people will keep developing it and lose track of it's already good enough for the business, and now we just getting diminishing returns. We putting a lot of effort into the model, but it just increases to the point that it's not noticeable by the client, and that delay costs them more than the increase in the performance. Done is better than perfect. Speed is important in this world. And the more feedback you can get about the model, the better. So deploy it and see how it works, because your next iteration probably wouldn't be the better performance. It will be solving a slightly bit different problem because you have different data. Maybe your labeling will change based on what business tells you what's important. But there are key differences between ML and software development. Machine learning is exploratory and research in nature. You don't really know what's the final outcome when you start the project. You just know it will be some sort of black box that will be plugged in, but how will you build it? What are the labels? When you're starting, you don't really know. It clarifies as you go along the process, but at the beginning, when you know project like predict churn, you're like, sure, what is my label? When should I tell someone is churning? So meaning they not returning to the page or not. Agile, but taking it step further, there are big error bars on estimate. If someone asks you like, how long it will take you to build the model? You're like, I have no idea. There's so many unknowns along the way that it's really hard to say. And then outcome of every task will dictate your next step. It's very hard to schedule like 20 steps to build a model because you're going back and forth. Depending what you're finding in data, you will do different things. And in the end, you can be lucky and building in the one iteration, or unlucky and take 20 iterations to build some good model. And there is more to version than just code. There's data, there are models, code, of course. And not only code to review, there's EDA, model performance, data quality. So looking at different things than just model when you can spot the bugs. And QA is crucial, but a lot of that is dependent on data, whereas in software, you're writing a lot of tests. In machine learning, I hope we'll start writing more and more tests, and there will be good frameworks for testing models. But a lot of tests are these model performance tests, and that depends what actually is your experiment setup. How did you divide? Did you overfit or not? So a bit different approach to quality assurance when it comes to development. You cannot just look at the data, but there is also data just look at the code, but also about the data and your setup. So finally, I wanted to speak from the business perspective. What do we use to optimize the models? Is it accuracy, F1, AUC? Well, should we, maybe it's not the best, accuracy is a bit flawed, 70% accuracy, you don't really know what it does. F1 score, sure, but there is difference which true positives or true negatives. AUC doesn't really optimize probability maybe for what you want, but probably I would say the best, because at least it optimizes the probabilities output of the model. So maybe we should show confusion matrix. I have a joke, but as the name suggests, confusion matrix will confuse anyone who looks at it from the business side. So my solution would be optimize model to provide most business benefits. And what it is? Well, most often it's profit. So use profits as a metric. Try to convert the problem so your metric is actually dollar amount, and business will understand that. But having a metric is only one step. to selecting the best model. Every action in real world has a cost. So you can prioritize those actions. So let's think about somewhere where you predicting churn of customers, and then you can build a model that predicts this churn based on probability. You can sort it out, and then you can ask customer, how much does it cost to reach out to those people? Is it like negligible, or does it actually have some cost because someone has to call them? And then you can start plotting this return on investment curve, where basically as much of the data you're willing to invest. So let's say you have some budget and you know how much you can invest, how much return you will have. And if you build a good model, this is the perfect scenario. You will just keep increasing investment as you investing in it. But then at some certain point, you will start losing money because, you know, these people were not churn, for example, but you're predicting them as churn, and then you're spending money where you didn't have to. So on the random model, you will just keep losing money. But when you're building some good models, you will get this plateau here, where this is the point where you can analyze and actually stop the investment, build the model, say like, oh, you should invest 10% of the sample, so you can tell them how much they should do to maximize their return. There's more things that we can do with that, with some uncertainty. You can have bootstrapping and generate some confidence intervals, and you can also since often when you're collecting data from customers, asking them, what's your cost, what's your benefit, they will say, well, it's between 50 and 100 for benefit and $10 and $15 for the cost. So you can plot the number, see how the different curves looks like, have some confidence intervals, and then you will actually realize it doesn't change too much, but gives you a bit more stability where you can select the right point. So what I wanted to convey here in this presentation is a lot of the people focusing on the data science career, on this machine learning development career, focuses a lot on technology, but there's other things that you should be looking at, this business sense and making sense that what you're building can be used by business, asking a lot of questions, why, how it will be used, how we can integrate this model. That's very important. And then translating this model to business, to some metrics that business will understand. So thank you, everyone. And will happily answer some questions.
So first question we have is from Tani. She said, do you think that the market is moving towards dividing the data science work into different specializations as you've presented?
I believe so. For me, data science is more about the team. So actually, these multiple specializations are needed to perform data science. There are, of course, even if you go into machine learning, there is computer vision, NLP, audio, multiple domains, but people have to have knowledge. So yes, in the essence, I think this division is happening, and then we'll see more and more roles that will actually tell you more about what people are doing within a team. But they would still be the part of a big team, but the main benefit is to extract the knowledge from the data and make it usable.
Thank you very much, Tani, and thank you, Marcin, for that. We have another question from Brian. Brian has asked, he said that you mentioned that one needs to version more than just code. Do you, or how do you suggest versioning data?
That's a good question. There are some solutions. What we are trying at AltaML, we're trying to use some tools that has this versioning built in. Strange enough, a lot of those tools do not handle versioning. They're brilliant to build the framework, but then the version is either higher tier package, which I understand, or they don't have the support yet, which I don't understand. That would be the first thing. There is DVC, data version control, that's an open source framework. We built some layers on top of that to enable also access. But basically, that's still a problem that I would compare to like 90s in software development, where there were some versioning systems that they have been developed. So I don't think there's good tool set yet, or maybe I'm not aware because new tools are showing up daily. The one I think that is very popular is this data version control, DVC.
Great. Hopefully that answered your question there, Brian. We have another question here from Pat. Pat has asked, as an agile practitioner, I've worked with Scrum. Do you see data science teams using MSTDSP or CRISP DM?
I would say yes. I don't know if a lot of teams even realize they're using them, because that's more like the framework, but especially this CRISP, and I would say the latter two are extension to that. It just describes the chaotic process of brainstorming and modeling, where you're moving between the stages. Of course, you first understand the data, well, business problem, then you understand the data, then you process the data. If you process the data and actually you see the business problem cannot be solved, you're going back to defining business problem. So it is there, but it's also pretty chaotic. It's more of a process. When you compare it to the Scrum is a bit different. It chunks your work into sprints, and that's problematic with data science because of what I said, big error bars on estimates and a lot of the tasks defining what's next. So that's somewhere where people are, I talk with a lot of people that tell me that I'm using Scrum for data science, and how does it work for you? And they're like, well, it could be better. There's these challenges. So Bootcamp has interesting Scrum-like, well, and they would be probably offended if I say Scrum because it's not Scrum, but agile methodology shape up, where you investing appetite, but you don't really have the tasks, and then you have these phases where you start exploring, adding tasks, and then you start solving them along the way. I think something like that is maybe better fitted, but we still experimenting to find some good balance. And we're using something like this, some variation of this CRISP MSTDSP in AltaML for our projects. When we working with the customer, we have the phases, and we're going through that business data, business validation with customer, and then model development, and then presenting business value, and it goes to integration and so on.
Excellent. And one of the final questions we have for this evening, yeah, definitely. What are the technical skills you look for in a machine learning developer?
That's a good question, and I would say it depends to which team. But in general, at the entry level, I would expect programming knowledge and some good theory of machine learning. A lot of the skills can be learned, so I would even say we're looking more on is person willing to learn, creative, coachable, are very eager and passionate. And then if you want to get more senior, then how much of these problems that I was mentioning you actually pay attention to, where you're exposed to these problems with business, where you're exposed with all these software development practices. Did you lose data? Did you start versioning it? Were you not able to reproduce your results, and then you started doing something about this? So more experience and going through those pains of developing models.
Great. We have a couple of other questions, actually. Is AltaML a consulting company? Do you have data AI products in development?
So yes, we don't like to call ourselves consulting company. We don't do this traditional consulting. We're a product company. Now, there are two types of products. One product is when we're developing a model for a specific company, which can be seen and mistaken with consulting sometimes, because it's kind of the services for them. But the strong focus is to have this model that works, and then we helping them to maintain the model or keep building new models. And we're doing a lot of this side of services actually to find interesting problems that could be generalized, and then partner with other companies, with those companies that have this problem, and build a product to bring it to market and start selling. So we have 2 products that are currently being developed. One came from this stream of working with companies, predicting how likely companies to win proposals. And the second is very interesting. It went through this traditional, we call it deep dive, this project where we finding if something is possible. That application predicts if cat is happy or not. And it sounds funny, but there is really big problem behind it, because cats are very good at hiding when they're sick. The only indication is when they're actually unhappy. And it's really hard to say they're unhappy. It's possible, but you have to be trained. Based on the whiskers, ears, you can say that. And funny story, the developer who was working on that tested it on his cat, and the model showed the cat is unhappy while it was happy, and then it became unhappy. So he was like, he has high confidence in his work, so he went to vet, and it actually was some disease that was happening with that cat. So
Wow.
it's in the very alpha phase, but I think there's a lot of interest. So application like that will probably show up soon.
Cool. Yeah, that sounds super interesting. Yeah, cat emotions. Hey, I was speaking to somebody yesterday. They did a startup for artificial, like emotional intelligence, like detecting people's swiping patterns to see if they're engaged or happy with the content. Or yes, super interesting. We have another question from Avernus. Can you mention some of the domains for which AltaML has developed ML solutions?
Yes, so we don't really focus on a single domain. It will be very long list if I want to mention all, but given we're in Alberta, there's of course oil and gas, but also health. Alberta is pretty interesting because a lot of the data is centralized. For example, we're working with DynaLife, is like the medical imaging company, construction, smart cities. There's agro, industry, forestry, electricity, utilities, where various clients are coming from various domains.
Great. Looks like we've actually got some more questions for you there. You're hot property today there. We got a question from Chengui. I'm sorry if I pronounced that miscorrectly. Since AltaML is in Alberta, are there any other projects and products from the oil and gas industries? How do ML and DL can help oil and gas industries reduce pollution?
Yes, so absolutely. We actually working with a few companies in oil and gas. And funny that you mentioned reducing pollution, because one of the projects that we're looking into working with is greenhouse gases reduction analysis, and then how we can reduce greenhouse gases.